Alright, we're back. Alright, here's our lifter blocks. Let's check to see what our clearances are on these. Everything's brand new, so it should be good. It's probably going to be good and loose, I bet. If you can see the bores in there. They're pretty black looking in there for whatever reason. They are definitely not tight. You can hear the end plate going up and down in them. They're definitely loose. You can look at the gap right in here. You can see it also. It's supposed to be 1 to 2 thou on those. This thing's got at least 2 thou in there. Pretty easy. Long ways from being tight, that's for sure. It's better to be a little loose than tight, so I'm okay with that. Alright, so I'm alright with that. Okay, feels good. Not sure what's going on these bores in here. I might fill these in my hone real quick to knock off any burrs. Probably will. The hone will knock off any high spots and trash that's left over. When the rod's set, let go, put a lot of metal throughout the motor. Cast iron is soft, the metal can embed into there and stick in there like a high spot. And the lifter would rub across that and eat itself up. So if I run the hone through there real quick, it'll knock off any high stuff. And loose stuff will come out too. I use a really fine hone, so I'm not really taking metal out. I'm just kind of knocking stuff out of the way and taking burrs off. So I'll probably run these through the hone. Just because I like doing that stuff. Okay, now where's our cam at? Check our clearances here a little bit. Put a washer on the end of that. Put that on your cam. And see how loose it is. We call that not tight. Looks pretty bad. Now, the way you know for sure is you push straight down on it and move it side to side. If it moves side to side, when it's straight up and down, you know it's loose. If you're just going like this, it might be tight in the middle of the bush, and the bushing might be hourglass shaped. It might be tight in the middle, but loose on the side. So, hear the side to side movement? That's a lot. So that bushing's definitely loose. Okay, so that should be replaced. Plus it's got a lot of metal in it too. So that's one more thing we got to do. Add it to the list. Okay, we'll put that over there so we got to work on it. We got our circuit breaker gears here. Go up and down, you can feel the wear and things already. Oh yeah, it's heavily worn. It's hard to believe that's brand new parts. With only 200 miles on it. You can actually feel the lip right there. It's a big lip in there. This side over here you don't feel anything. You don't see anything either. Right here it's got some heavy wear right there. So why would it be wearing real heavy on that one side? The only thing I can think of is when they had the circuit breaker, when they had the idler gear in here, like that, they put the generator in here and they tightened it down on the saddle and they didn't shim it. So the gear teeth basically were bottoming out inside the gear here, and then it was pushing really hard this way and made it extremely tight. Had no clearance, and that caused a lot of wear in the shaft. You can see the wear in these. I go side to side like that, but you go side to side like this, see? When you got that kind of clearance like that, that means it's really loose. That's more than 2 thousandths. Now a lot of that is the shaft. But see, it's loose all the way around. See, it's loose at the top, bottom, and it's loose over here where the wear is too. So that bushing's worn out pretty heavy. That would still work in there, just the motor sounds like it's got a bunch of loose marbles in your motor, like a concrete grinder going on. Where's my idler gear at? Right here. Now, this one here has new bushings in it, but who knows what they were made to fit. So we come out of that bushing. So we're only doing the one right now. See how it's got some clearance? Not too bad. Same thing, not too bad. Okay, then you put the thing in there like it's supposed to be. And now we're going to go back and forth, pushing down and going side to side. See how we're not getting that clearance like we did before? There's clearance in there, I can feel it. See, it's not clicking. It's only like about a thou in there. Versus this one over here, which has probably 5 thou clearance in the damn thing. That's the difference. Now the gear that came out of it was over here. See how much looser that is? You just barely hear the clearance, but you can see the gap in here. So these things are pretty loose. So these bushings are loose too, which is okay because we're not using it. Okay. This shaft here, I don't really feel a bunch of heavy wear in it like I did the other one. There's definitely some wear right here. You can see the wear mark on it. You can feel the change right there. The rest of it feels nice and straight and true. There's a little bit of wear right down here in the heavy spot down there. So this one here could have been caused by this gear pushing against it, but it's worn on the top up here. Not sure why it's got so much wear on the top surface. There's no real load on the top surface. But this thing I distributed was in there all wrong. You know, binding up pretty heavy, so my guess is that's probably why it's got a wear problem on the top surface. Because the worm gear was in there pushing it pretty hard, I bet. We fixed that when we bushed the case and put it in the correct spot. So we took that problem, took care of it. Alright, so this shaft here has got a lot of wear in it. I don't know if we can measure that wear, but we can try. It's hard to measure wear a lot of times because it's not consistent. The gear goes back and forth like this, so it wears on the high spot, puts a little divot in there, but with the mic it's 1/4 inch wide, so it doesn't measure the depth of the wear part. So let's see if we can get anything out of this one. Plus I can't exactly measure in the right spot because the other shaft's in the way. Okay, that's 5 there, 4 3/4 there. Four and a half down there. 4 and a half, maybe 4 3/4, and almost 5 right there. So I can only measure half a thou because of the way, because I can't really get in there very well, and it's a wide base on the mic. I can actually move the mic like this because the shaft's uneven, but I can't measure it. It's too wide. See, I'm a half a thou under, but even though I'm tight there, see how the mic is moving up and down? Because the surface is not square. not flat. So you can't measure it. It's there, but you can't measure it. At least not like this. We know for sure it's got at least half a thou. Because I can measure that much. But it's got more than that. Alright, so it needs a new bushing on there. A new bushing would probably be enough to take care of what really matters. But the shaft is definitely worn. We'll see if the customer wants to change any of that. This other shaft I think is fine the way it is. And when the new bushing's on there, it fits good and feels good. So I'm good with that. So this one's good. This bushing here is worn out, needs to be replaced. Can bushing needs to be replaced. We already bored out the breather hole and fixed it, so we know that's good. Okay, so now what I need to do is check our shaft. So I got to figure out where the crankshaft is at to get the main shaft so I can check it. Basically, I'm going to take this, stuff it in the hole right here, put your crank in here, and feel how much clearance you got. That's how you do it. That's if you're rebuilding this stuff. So we have niche parts if we need it. If we don't need it, we don't. Well, if you can see the wear mark in there, the shininess versus the dull spot. It's kind of hard to see. You're looking at the shadow changes mainly on this kind of stuff you're looking at. So, see there's a lot of wear on the part of it. So, there's no lips I feel, but it feels alright. Needs to be honed, but it feels alright. This one over here, same kind of thing, it looks okay. There's no flaking or stuff, it does need to be rehoned. Alright. And we did a lot of machining on these cases, so we're not sure if they're really straight with each other either. That's a whole other problem. So what we're going to do is we're going to bolt these things together. Make sure they're clean. Well, they're both together nice now. Used to be I had to beat them together. Oh, that was the other set. I forget, this is not the one I worked on. This is the reproduction set. Flat. Okay, I'm going to put the studs in this one. This one with the dowel pin holes are too big, so I can push them in without having to really do anything, which is not what they're supposed to be. You're not supposed to push them in with your hand, they're supposed to be a hammer and fit. They are what they are. It's half tight. There should be the next longest one. Two of these are the same length, so that's a short one. Short one goes right here. That thing's tighter than the dowel pin hole is. We're missing a stud here. We're missing this one for some reason. Where is that guy at? It's longer than these here. He's missing. These two go here. Oops. This one here is the other stud. It's supposed to be a dowel stud. It actually has tightness like it's supposed to have on it. Okay. This breather one goes over here. Okay. Now these I got to beat them until these motor mounts are perfectly flat, because that means all this is flat. Because all this stuff is machined perfectly flat. Okay, we'll go with that. Okay. Go back and check that. Hear my finger hitting on the high spot. Not that way. Go down a little bit. A little bit better. So we need to go up a little bit. It's kind of moving around a little bit pretty easy. Not how it's supposed to be. Oh, there's a missing stud. Oh, it fits. That time I left over by the milling machine. It was under the vise so I couldn't see it. Good. I was getting worried there for a minute. I knew it was around someplace. Alright. You gotta know the torque of your tools when you're using power tools. Okay, so this is all together pretty even, much we're going to get out of it. It's a little different than it was, but it's pretty close. Alright, so now this needs to go into the hone, and we line hone it straight through and see how the holes line up with each other. So these are the old races, so we don't have much to work with. They make bearings up to 1 thou over, so I can go up to 1 thou over diameter, which is 1 thou per side, 2 thou bigger total. And I don't know the clearance because I haven't measured all the numbers, but the bearings are 1/2 thou under. That means it's 1 thou less right there. We lost the hone hat here, and if the shaft is undersized, we're screwed again. I have to get the crank and measure it and figure that out. So initially, I'm just going to go hone this real quick and kind of get an idea of what we're looking at. A quick flash hone will tell you more about alignment than anything. So that's what we're going to do. So I'm going to find some parts. We'll be back.